In this lesson, we are going to graph a linear relation from a table of values. So in the workplace, a person's gross pay that is represented with P often depends on the number of hours worked, which is represented by H. So we say P is the dependent variable because the amount of pay that you get depends on how many hours you worked. And the number of hours worked would be the independent variable because it does not depend on anything. You get to choose, typically, how many hours you work in a day. So the independent variable, the variable that you get to choose, is always going to be in the X part of a table of values. And the dependent variable, something that depends on something else, will always go in the Y part of the table of values. So again, the independent variable is a variable for which values are selected. So you can choose if you would like to work for 5 hours or for 10 hours this week. And this is always plotted on the x-axis and in the x part of the table of values. The dependent variable is a variable whose value depends on the independent variable. So the amount that you get paid depends on how many hours you worked. This is always plotted on the y-axis and is in the y part of the table of values. We have two different types of data. We've got discrete data that can be counted and is not a continuous number. So for instance, the number of cars in a parking lot is discrete data because you can have 1 car or 2 cars or 3 cars. It doesn't make sense to have 2.5 cars in a parking lot. So these would just be whole numbers. So sometimes data are continuous but measured in a discrete way. So for example, your age. So yes, it is continuous because you can be 15 years, 5 months, 3 days, 4 hours, and 33 seconds. So that would be continuous because it's always changing. But we typically represent this in a discrete way and say, I'm 15 years old. Continuous data can have almost any numeric value and can be meaningfully subdivided into finer and finer increments depending on the precision of the measurement system. So for example, time is always continuous because time will never end, it will keep going, and we can divide it into months or weeks or days and get even more specific into minutes, seconds, milliseconds if we have something that will measure down into the milliseconds. So time is continuous because it can be any decimal value and we can break it down into smaller and smaller increments. For continuous data, if you're drawing a graph, we're going to join points. We're going to connect the points. And for discrete data, we are not going to connect points. So if you are graphing something and you have discrete data, we do not connect the points. If you have continuous data, you do connect the points. So now we're going to look at a couple of situations, and we're going to graph the information and then answer some questions about it. So the table of values shows the cost of buying a chocolate bar. So in the X part, we have the number of chocolate bars that are bought. Again, you get to choose this number. You get to choose if you want to buy 1 chocolate bar or 2 chocolate bars. So that's going to be in the X column. That will be the independent variable. The cost of the chocolate bars is dependent on how many chocolate bars you buy. So the cost is in the Y part. That will be the dependent variable. So we want to graph the data that is shown in our table of values. So when we graph the data, first we have to label our X and Y axis. So in the X column of our table of values is the number of chocolate bars. So I'm going to put that down as the X part. So number of bars. And in the Y column is the cost in dollars. Okay, so now I need to make a scale. So I don't want to use just a teeny tiny corner of my graph. I want to use as much of the graph as possible. So I'm going to space things out as much as I can. So for the number of chocolate bars, our table of values only goes up to 5. So I'm going to use every fourth line. So here is 0, and then 1 chocolate bar, and then the same distance apart would be our second chocolate bar, same distance apart again. Okay, so our graph has to be spaced out the same amount between each value for the X part. So I don't want to leave 2 spaces between 0 and 1, and then 5 spaces between 1 and 2. I want to keep it consistent all the way along. For the cost, again, same thing, I need to make a scale. And because I need to get up to $17.50, I'm just going to go up by 1. So 0 would be the bottom part, then we'd have 1, 2, 3, 4, 5, and then I'll go up 1, 2, 3, 4, 5 to get to 10. So I don't have to label every single line of the graph. That just gets really squishy and really messy. So I just need to keep it consistent. So now putting the data onto the graph. So if I have 1 chocolate bar, it's going to cost $3.50. So here's the $3.50 is going to be right in the middle. Just approximate as best as you can. 2 chocolate bars is going to be $7. 3 chocolate bars is $10.50. 4 chocolate bars is $14. And 5 chocolate bars is $17.50. Okay, so there's our data that has been graphed on the graph. So the rest of part A says, is the data discrete or continuous? And do we join the points? So when we're trying to figure out if it's discrete or continuous, we want to think about using decimal values. Does it make sense to use decimal values in both the X and the Y variables? So for the X variable, that's the number of chocolate bars that we're buying. So think about it, do you go into a store and buy 2.5 chocolate bars or 2.3 chocolate bars? No, we don't. We only buy 2 chocolate bars, or we buy 3 chocolate bars. So it doesn't make sense to use a decimal value. So that means that it's going to be discrete. So those are just the counting numbers. We can count how many chocolate bars we get. So that is discrete. And when it's discrete, we do not join the points. So do we join the points? No. Because we can only buy whole number of chocolate bars. The second question, it says, is the relation linear? So if we look at the graph, it looks like our graph is going in a straight line. If you look at the table of values, our X values are increasing by 1 each time, and our Y values, the cost, is increasing by $3.50 each time. So yes, this is linear. Is this partial or discrete? So in order to determine if it's partial or discrete, we need to know if it goes through the origin or the point 0, 0. So it looks like it's going to, if we would have connected the points and continued on, continued our line on, looks like it goes through the point 0, 0. But to check for sure, we can create that previous data point on our table of values. So if we go backwards 1, we will get to a value of 0. from 350, if we go, because our cost is 350 each time, if we go back 350, we will also get to 0. So if we buy 0 chocolate bars, we will pay $0. So therefore, our relation is direct. Next question, is it increasing or decreasing? So as we start from the left-hand side of the graph, our graph is going up towards the right, so this is increasing. What is the y-intercept? So the y-intercept is the point where x equals 0. So we have the point 0, 0. So our y-intercept, which is represented by b, is 0. What is the slope? So the slope we can figure out using our slope formula. So y2 minus y1 over x2 minus x1. If I choose 2 points that are on the table of values, I'll use 1 and 350, and 2 and $7. So to figure out the slope, we're going to have m equals y2. I guess I should label these first. So x1, y1, x2, y2. So we'll have y2 is $7 minus y1 is 350. In the denominator, we'll take our x2, which is 2, and subtract our x1, which is 1. So when we calculate this, we will get 7 minus 350 is 350. 2 minus 1 is 1, so it'll just be 350. So the slope tells us that each chocolate bar costs $3.50. So moving on to the next part, says determine the equation of the relation. So our equation is of the form y equals mx plus b. We know what the y-intercept is. The y-intercept is 0. We know that the slope is $3.50. So we can sub those two values into our equation. So we will get y equals our slope of m is 350 times x plus our y-intercept, which is 0, so we don't need to show a plus 0. The last question says, what is the cost to buy 25 chocolate bars? So there's a couple different ways you could do this. You could extend your graph to figure it out. You could continue your table of values to figure it out. Or we can use our equation to figure out what the cost to buy 25 chocolate bars is. So in our table of values, the x part was the number of chocolate bars, the y part was the cost. So we actually have the x value, because that's the number of chocolate bars. The cost is represented by y, so we're looking for the y value, and we're going to sub the 25 into the equation. So when we multiply this, we've got $3.50 times 25. So if we bought 25 chocolate bars, it would cost $87.50. In this next example, Amy is planning a banquet dinner. The caterer charges a flat fee of $150 plus $15 per person. The table below shows some costs. So not all of them, but some specific points. So first we want to graph the data. So our x value is the number of people that attend, or that could attend, and the y value is the total cost of running the banquet, depending on how many people attend. Okay, so our x column is the number of people, so that is the independent variable. You can invite as many people as you want. And then our y variable is the total cost. So the cost depends on the number of people, so that's the dependent variable. And again, it's the cost in dollars. Okay, so now we want to set out our scale for each of our x and y axes. And again, we need to go up to 50 for the number of people. So I'm going to go up by 4 lines again. So we would start at 0 and 10. For the cost, we need to go up to $900. So I'm going to say that every line is going to be $50. So for the second line, we'd have $50, $100. So if it doesn't get to the very top of the graph, that's okay, as long as it uses quite a bit of the graph. So now we want to plot the points. So when we have 10 people there, then it will cost $300. If there are 20 people, it will cost $450. 30 people is $600. For 40 people, it's $750. And for 50 people, it costs $900. So that's the first part of A. The second part asks, is the data discrete or continuous? So again, to determine that, we need to think about, does it make sense to use decimal values for the number of people and the cost? So for the cost, it makes sense to use decimal values because you can have cents, right? For the number of people, it doesn't make sense to use decimal values because you can't invite 10.5 people. You can't have half a person or a quarter of a person. So this is discrete data because of the people. So therefore, we do not join the points. We don't join the points because we can't invite half a person. Part B asks, is the relation linear? So if we look at our graph, it looks to be in a straight line. If we look at the table of values, our x's are going up by 10 each time. Our y's are going up by 150 each time. So therefore, the relation is linear. Is it partial or direct? So if I did draw a line to connect the points and continued it backwards to the y-axis, it would not end up going through the point 0, 0. If I look at the table of values and I go back to x equals 0, so I decrease by 10 again. And in the cost, everything is decreasing by 150. So if I take 150 away from 300, I will end up with 150. So because it doesn't go through the point 0, 0, this is a partial variation. Okay, is it increasing or decreasing? So as I start from the left-hand side of the graph and work my way to the right, it is going up. So this is increasing. Now, what is the y-intercept? So the y-intercept, we go back to the point where x equals 0, and we figured that to be 0, 150. So the y-intercept, represented by B, is $150. What is the slope? So I can calculate the slope using the slope formula. So I'll take the points 10, 300, and 20, 450. Again, you can use any 2 points that are given to you. So I'm going to label this x1, y1, x2, y2. And when I calculate the slope, we'll start with our y2 of 450, take away our y1 of 300. We'll divide this by x2 of 20 minus x1 of 10. So when we calculate this, 450 minus 300 is 150. 20 minus 10 is 10. So 150 divided by 10 is $15. So notice that the question said that the banquet costs $15 per person, which is what our slope is, plus the extra $150 flat rate, which is what the Y-intercept is. So finding the equation of the relation, again, we're using y equals mx plus b. Our slope is 15, so we'll have y equals 15 times x plus the Y-intercept of 150. Next question says, what would the price be for 45 people? So in our table of values, the number of people was the x in the x column, and the price was in the y column. So we know that we should substitute 45 into the x part of our equation. So we will have y equals 15 times 45 plus 150. So this means $15 for each of the 45 people, and then the extra $150 for the flat rate. So we will have $675 plus 150. So the cost would be $825. The last question says, how many people attended if the price was $1,680? So how many people, that is the x variable, and the price, again, is the y variable. So if we look at our table of values, in the x column is the people, in the y column is the cost. So we will have, our y is 1680, and this equals 15x plus 150. Now we need to solve the equation, so we'll subtract 150 from both sides. When we do that, we will get 1530 equals 15x. We'll divide out that 15. So our x value will be 102 people. So if you asked 102 people to come to the banquet, you would have to pay $1,680.